In this video, let's talk about how you can simulate a partial building, which is much faster than simulating the entire building. Let's assume that you want to simulate a high-rise apartment building. Each unit is one zone, and the corridor on each floor is a separate zone. Simulating this model takes many times longer than a single zone model. Because the units are repetitive, you can simulate one unit to represent the EUI of all other units with similar conditions. Let's start with a blank Rhino file to see how we can simulate only one unit of the building. Let's create a box with the dimensions of 12 meter by 8 meter by 2.7 meters. Select the box and create a zone from this box. Set building type to residential and space type to high-rise apartment. Set the window to wall ratio to directional, 0 for north, east, and west. Keep the south to 40% and click OK. If you run the simulation as is, Climate Studio treats this model as a single-family house with the 5 surfaces exposed to the exterior and the bottom surface attached to the ground. So there will be heat transfer through all 6 surfaces of the unit. But in our design, this unit is sandwiched between units, so there's no heat transfer through the walls, the slab, or the ceiling if the adjacent units set the indoor temperature to the same set point. So to simulate the no heat transfer condition, we can model the surfaces as adiabatic surfaces. For the pure purpose of comparison, let's run this model as is. The EUI is 305, much higher than the baseline. Let's model the adiabatic surfaces. Copy the box and delete the zone. Explode the box, delete the south facade. Select the rest of surfaces and move them till they overlap with the zone. Click Add Adiabatic Boundaries. Now you see the 5 orange surfaces, which represent the adiabatic boundaries. At the bottom of the model, you can still see the ground slab in green, so let's delete the ground boundary. Run simulation again. The EUI is 73, which is substantially lower than the previous simulation results of 300 plus. We just simulated one of the south side units. It has a very different climate condition from the north side units, so you need to simulate one north side unit separately. Also, it is likely that there are minor differences between the typical unit and the roof unit, the ground unit, or the corner units.